Okay, welcome back everyone. This is lesson number 3. If you remember last lesson, we talked about triangles and the fact that the angles inside a triangle always add up to 180. I'm going to write that to the side again because we'll use it again today. The angles inside a triangle always add to 180 degrees. And I showed you this little symbol that you can use, just a little triangle with the angles sort of pointed out, so that you don't have to write that sentence out every time. Now, what I'm going to do this lesson, we're going to talk about quadrilaterals. And a quadrilateral is just a four-sided shape. So I'm going to draw any old four-sided shape. Here's my quadrilateral. Quadrilateral is just a shape with 4 angles and 4 sides. 1, 2, 3, 4 angles. 1, 2, 3, 4. Now, there's actually not much that we need to know about this other than any single quadrilateral, any one, can be separated into 2 triangles. We already know that the angles inside a triangle always add to 180. I just realized I've made that a plural. We'll get rid of that S. We already know that the angles inside a triangle always add to 180. And here in front of us, we have a quadrilateral, and I've shown you that it's made up of 2 triangles. That's going to be true of any quadrilateral. Here's another weird quadrilateral. Draw it a bit smaller. One, 2, 3, 4 sides. 1, 2, 3, 4 angles. Just like the previous one, it can be separated into 2 triangles. It doesn't matter what quadrilateral you choose, as long as it has 4 sides, it can be turned into 2 triangles by drawing one line down the middle. If we know that a triangle's angles always add up to 180, and in a quadrilateral we know we have 2 triangles, then the angles inside a quadrilateral must be 2 times that of a triangle. We have 2 triangles, so the angles are going to be double that of a triangle. So if these angles, this one here and this one here and this one here, equal 180 degrees, and these angles, this one here and this one here and this one here, also equal 180 degrees, then these 2 together must equal 360 degrees. And that is the case. Any quadrilateral, any 4-sided shape, the internal angles add up to 360 degrees. I'm going to show you the working out on the side, because if we were in an exam, we wouldn't write it like I've written it here. It's not very mathematically correct. What we'd actually do is we'd name our points like always. So here's point A, here's point B, here's point C, and here's point D. What we would say is triangle A, B, D, triangle A, B, D, whoops, I've drawn a C, A, B, D, A, B, D, equals 180 degrees. And triangle D, B, C, D, B, C also equals 180 degrees. And then I'm going to use this little symbol for the first time. And what this symbol means is therefore. So I've said triangle ABD equals 180 degrees, and triangle BCD, DBC, sorry, getting my letters mixed up, equals 180 degrees. Therefore, quadrilateral ABCD equals triangle ABD plus triangle D, I'm running out of room, B, C, which equals 180 degrees plus 180 degrees, which equals 360 degrees. That'll be how I'd write this out. Nice and simple, nice and neat, even if I don't have this image here. Even if I don't have any of this, my working out over on the side here makes sense. And if you remember from my last video, I said I would try really hard to keep my equal signs directly underneath each other in a big straight line. And I've done that. So now my working out is really straightforward, and I haven't even used a single word. The only one I actually wrote here was therefore, but I could cross that out now, because we know that this symbol means therefore, these little 3 dots. And so that's actually all we need to know about quadrilaterals. As soon as we realize that a quadrilateral is just a 4-sided shape, that it can be separated into 2 triangles, and we know that a triangle equals 180 degrees, the internal angles that is, if we have 2 of them, a quadrilateral must equal 360 degrees. And that's everything we need to know about quadrilaterals. So thank you very much for following along for this next lesson. The next lesson that I will be uploading will be one on a fully worked problem-solving example, so that we can see the working out and the process that we go through to solve a more complex multi-step geometry problem. So look forward to that, and good luck.